Now, this next section here, I'm just going to go through very quickly some of these WAN technologies. And the reason I'm going to go through so quickly is because I'm not expecting you at this point to be an expert on how these technologies work. I want you just to understand that the technologies exist so that if you are researching the need for connectivity between one office and another, you know what some of the options are that are available to you. So first of all, I have here something called circuit switching and packet switching. Circuit switching is where a physical connection path is established between the source and destination through a series of circuits. Okay, so there's an actual path that is created through different circuit switches, and once that path has been established, all data will travel along that path. Whereas packet switching, which is more commonly used in today's WAN environments. Okay, the circuit switching was the older, less sensible, slower, more expensive way. Packet switching is where data is broken into packets, which can then each take a separate independent route to the destination where they are reassembled back into data. So many of the WAN technologies that are out there are what's called packet switching technology. And in order to get data from point A to point B faster, rather than having them all, and when I say them, all the different packets of data, all the different bits of information, traveling one behind the other down the exact same path, we can have multiple packets transmitted at the same time, each looking at what's going to be the fastest way for me to get there, subject to what's available. And it may not be the same path, because the same path I may have to wait and follow the other one. Whereas there might be two paths that are about the same speed. One can go on one can go on the other. They get together in the end, they get reassembled into data. Now, as far as some of the specific technologies, back in the old days, we used to all use the POTS or PSTN, which is plain old telephone service or public switch telephone network, right? We used to use dial-up. Some areas of the world still use dial-up today, but most have moved past it. Dial-up maxes out at about 56 kilobits per second, what's considered to be extremely slow by today's standards. We have a couple of dedicated digital leased lines, which the first we'll talk about here is the T1 or the E1. A T1 is 2464 kilobit channels, providing a transfer rate of up to 1.544 megabits per second. And the E1 is just the European version, which gives you 30 channels, so you get about 2 megabits per second. I can tell you that back in the 90s, this was considered to be high-speed internet. So back in the 90s, if you had a T1 line, you were considered to be king. You could do anything on the internet. Whereas by today's standards, 1.5 megabit on the internet is not considered to be that fast. We also had a much faster dedicated digital lease line called the T3, which is 28 T1 lines, which gave you a transfer rate of up to 43.232 megabits per second, right? So we're now up to 43 megabits per second. And we had the E3, which is the European version, which gave you a little over 34 megabits per second. These are still available today, although again, typically not used quite as much because we have much more cost-effective options that are available. Another older WAN technology was something called ISDN, the Integrated Services Digital Network. I'm not going to spend a whole lot of time here. I just want you to understand that ISDN is something that was broken down into two different flavors. One was called Basic Rate ISDN, so BRI, which would give you two 64 kilobit B channels to transmit data on and one 16 kilobit D channel for the control information, which meant that your data throughput was about 128 kilobits. This was considered to be really good back when we were using dial-up. And we also had a primary rate ISDN, which was essentially a T1 line. I mean, it was almost the same throughput as a T1 line. You had 23 64K B channels for data and one 64K D channel for the control information. So that's ISDN. The main thing I want you to remember there is the basic rate and the primary rate. We have something called SONET, Synchronous Optical Network, sometimes called a SONET Ring. This is a network technology designed to carry large volumes of traffic over relatively long distances via fiber optic cabling. The data rates of a sonic network are divided into what's called OC levels, or the optical carrier levels, and I have them listed for you here on the screen. Notice that we go all the way up to OC 768, which will get you 40 gigabits per second, so quite fast. And actually, these days, again, everything you see here, I'm kind of going through a little history lesson here. Everything today exceeds even what we see here. We had frame relay technology. This is a WAN where all nodes are connected through a packet switching cloud. And here was the big deal with this particular technology. You pay a base price for an agreed upon CIR, or committed information rate, right? So you have your base price, which gives you a guaranteed minimum speed, right? So you'd figure out during slow times, I still need to have connectivity at a base speed, and I'll pay you an amount for that. But then you could pay additional to go faster. In other words, when you hit busy times, you would use a lot more bandwidth, and then during those busy times, you would pay a fee for that additional bandwidth. This was a service that was sometimes referred to as bandwidth as needed. It was a great way to get high-speed connectivity, but not have to pay the prices for the dedicated high speed, pay a much lower price, and only pay a higher price when you actually needed it. We have something called ATM, asynchronous transfer mode. It was an advanced packet switching network using fixed length packets, all 53 bytes. Provides data rates up to 622 megabits per second, and actually we could double that through compression. Now here's something that we still see today: digital subscriber line. Many people have DSL in their homes. It provides high-speed internet connections using standard copper telephone wires. So it's a great way to get high-speed internet, but using your regular phone wires coming into the house. Now DSL had many different flavors. We had ADSL, asymmetric DSL, which allows POTS and data to be transmitted simultaneously. We had SDSL, symmetric DSL, which cannot share data transmissions with POTS. So you had a separate line, or you had separate transmissions between. When we say POTS, we're talking about just the regular, your voice, talking on the phone. And VDSL, very high speed DSL, which allowed the maximum bandwidth available to go anywhere up to 55 megabits per second. Now you see a lot of that today. At least you see a lot of that advertised today. They don't call it VDSL, but DSL, most of the carriers will offer you a high-speed DSL option. And they do this to try to keep up with the cable modem providers, okay? Because many of the cable modem providers are giving you these high-speed connections. And speaking of, well, that's the next thing we have on the list here. Cable modem provides high-speed internet connections using broadband cable connection. This is probably the most commonly used home internet connectivity today. And as a matter of fact, besides individual homes, I'll even go to small businesses. And the reason why is because it's a very cost-effective solution. I can tell you that at my house, I think I pay somewhere around, and I'm overpaying right now, but I think I pay around 30 to 40 bucks a month, and I get internet connections that are somewhere in the area of 20 to 30 megabits per second. Usually in the low 20s is what I think I've been noticing I've been averaging. Okay, so I get somewhere in the area of the 20 megabit per second speed for $30 to $40 a month. I'll tell you what, you go back a decade, and that was just crazy. 20 megabits per second. You were happy to be getting 1 megabit per second back then. We have satellite communications where we have high-speed internet using satellites. Where do we see this? Usually when DSL and cable are not available. Then you'll see satellite communications or satellite internet communications. And then we have wireless. Now, I'm not talking about the kind of wireless that you have inside your home or your office, but I'm talking about mobile wireless, right? The type of connectivity that you have from your mobile carriers. Sometimes you see it via Wi-Fi, right? That would be more of the wireless in your home or business. That's a Wi-Fi, and we'll talk about. We have a whole lesson on that. Or through the cellular phone network, which is something that is very popular by today's standards, where we have our 2G and our 3G and our 4G. I can connect to the internet on my phone, and I can get, I average pretty good around 6 megabits per second throughput from my cellular phone.